Alright, so welcome to what is probably our last online video lesson for this year. And in this lesson, we are going to be looking at statistical graphs. So these are visual representations of what's going on numerically when we're looking at mean, median, mode, distribution, dispersion, all of those things that we've done kind of in a more algebraic way. We also want to be able to sort of give a picture of what's going on. And so there are different ways to do that using these statistical graphs. So a lot of this today online is going to be kind of just giving you the definition of what these graphs are and showing you an example using a certain set of data. And then when we get together in class, we'll talk a little bit more about how you find or how you get these different graphs on the TI Inspire or how you would set them up for yourself. So let's get started. So as I said, statistical graphs are used to give you a picture of what is happening in the data, and there are 4 representations that we want to consider right now. We're going to be looking at the dot plot, which is also sometimes called the X plot. We're going to look at the box plot, also sometimes referred to as the box and whisker plot. We're going to look at a frequency distribution table and a histogram. So here's the data that we want to use. It says the following data set shows the scores received by students on a history exam. So you can see all of the scores listed there from 68 up to a high of 99. And we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 scores altogether. So that might come in handy later. Okay, 12 scores to use. All right, so let's talk about a dot plot first of all. So a dot plot is a graphing utility showing the frequency of different pieces of data in a set. Using a dot plot is ideal for small sets of data. It is similar to a bar chart, quickly showing you the mode, so that's a key to this. It shows you the mode of a set of data. However, it is different in that a data set does not need to be sorted in order to quickly create a graph. It is a good tool for changing data sets, as it is easy to add and delete data from a dot plot. Now with each of these definitions, I have taken them from the internet just to have a good definition of what they are. And so in each case at the bottom of the screen, you're going to see the URL for the page where I took it from. And in most cases, there's a lot more information about these things at those URLs. So if you're really interested more about any of these graphical representations, you could certainly go to the URL and find out more about them. Okay? But with that in mind, this is what a dot plot for our data of history exams would look like. Okay? So we start here, and you can see we have that pretty simple axis right here. It's just a single axis, so it kind of looks like a number line. And the numbers on that axis represent the test scores. Okay, and then each of these dots represents a single test score. So we mentioned that there were 12 test scores, and you'll see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 dots here in our dot plot. So each dot represents a score, and each placement of the dot tells us what the score is. So we can see here that our scale appears to be 4 from number to number, but yet we have tick marks in between, so it looks like we're going by 2s. So this particular dot represents a 68. And this particular dot would represent a score of 72, and so on. And then you can see in a case like this, where we have 3 dots, that represents the fact that there were 3 different scores of 86. And because we can see them lined up, we can also tell that 86 is the score that was earned the most, and so we can easily see the mode as we were told in our definition. So this is what a dot plot would look like, and as you can tell, this is something we can do on the TI Inspire, so I'll show you how to do that tomorrow. For right now, you just want to get a feel for what these different representations look like. Okay. Another representation is called the box plot, and a box plot is a graphical rendition of statistical data based on the minimum, the first quartile, the median, the third quartile, and the maximum. Now, we already know what 3 of those words are, but we might not be so familiar with quartiles, first quartile and the third quartile. Again, we'll talk a little bit more about this in class, but I'll show you on the plot what that actually is. So hang on to that for just a second. Continuing with our definition, the term box plot comes from the fact that the graph looks like a rectangle, a box, with lines extending from the sides. Because of the extending lines, this type of graph is sometimes called a box and whisker plot because the lines kind of look like whiskers sticking out of the ends. So here's what it would look like for our history exam information. Okay, so here's our rectangle that they were talking about. And then here's the extending lines out to either side. Now, notice that our scale here is still the same as it was with the dot plot. So we're still going from 66 up to 100 with tick marks going every 2. And if you notice where this endpoint lines up, that still ends up with the 68. So this endpoint represents the minimum score because that's still showing you 68. Oh, sorry. Okay. Now, the other end is the same. We have an endpoint here as well. And if we line that up, we'll notice that that seems to line up there at 99. So the other end of the other line is our maximum score, and that was the 99. Okay, now this line right here, change colors here for a second, this line right here that we're seeing, that is at 86. Now it would appear that that would be there because of it being the mode, but it's not because of the mode. It's because this line is our median. So our median appears to also be at 86 in this set of data. Okay, so now what are these two lines? What do they represent on the either end of the box? Well, these are what the quartiles are. This would be the first quartile. This would be the third quartile. And what a quartile is the median of half of the data. So if I take the first quartile, we're talking about the first half of the data from the minimum to the median, and then we want the median of that. So that appears to be here at about 78, maybe 79, I'm not sure if I can tell for sure. The nice thing about doing this on the TI Inspire is that as you move your cursor over that, it will tell you exactly what those numbers are. But you can see here that we have a score that is meant to be the median between 68 and 86. And that's what quartile 1 is. Okay? Similarly, we can do the same with the top half. So from the median up to the maximum, so from 86 up to the 99 up here at the max, we also have a halfway mark, which is our median, and that is what quartile 3 would be. So it looks like in this case, maybe we're looking at about a 90. Okay, so you are literally dividing your data up into fourths. You find the median, which is halfway in between your min and your max, and then quartile 1 is going to be halfway between your min and your median. Quartile 3 will be halfway between your median and your max. And so this box right here then represents the middle 50% of your data, because you're going from this half to this half. This box represents the middle 50% of your data. And then these represent the lower 25% and the upper 25%. Okay? So again, we'll talk more about how you get these in class tomorrow, but just so you get an idea of what it looks like and kind of what some of this terminology is. Our next graphical representation is called a frequency distribution table. And really a frequency distribution table goes along kind of hand in hand with a histogram, which is what we're going to talk about next. You really need to have a history distribution table before you can do any kind of histogram. Okay, so we start with the table, and it says statistical data may consist of a list of numbers related to a survey. Among those numbers, few may be repeated twice and even more than twice. The repetition of a number in a data set is termed as frequency. Okay, so we're just kind of keeping track of how many times different values, different answers are going to show up. So as the frequency of that particular number or the variable in which that number is assigned. The frequencies of variables in the data are to be listed in a table. This table is known as the frequency distribution table, and the list is referred to as the frequency distribution. Okay, so again, going back to our history exam scores, a frequency distribution table is usually divided up into 3 columns. The first column is for the interval, then you have a column for the tally, and a column for the frequency. When you do a frequency distribution table, you almost always end up with intervals of values that you want to set up. You hardly ever have just single values that you're looking at. That's more of a dot plot. So for the interval, you're oftentimes told, make a frequency distribution table with so many intervals. So in this case, let's say we want 4 intervals for our data. Okay, so how do we find those intervals? Well, first we want to find what is basically the range of our values. So remember, we had a minimum score of 68 and we had a maximum score of 99, right? But when I subtract this, I'm actually going to take 99 minus 67 because I want 68 to remain part of the quote-unquote range. So in order to keep 68 as part of my answer, I really need to be subtracting off anything that was 67 or below. So the 99 is my highest score, and to get the range of values, I'm going to actually subtract off the 67 because anything 67 or lower was not a score that was received. Okay, and so that actually gives us 32. So now if we want 4 intervals, we're going to divide 32 by 4, which means each interval should be 8 scores in it. Okay, so I can start then with my lowest score of 68, but 68 is one of the numbers in the interval. So I really need to count 68, 69, 70, 71, 72, 73, 74, 75 as the 8th score that would be in that interval. So my first interval is going to go from 68 to 75. Okay? My next interval then picks up where that one left off. So I don't want to start with 75 because I don't want two different places where I could mark a score of 75. So I start with 76. And then again, starting with 76 as my first score, I count out 8 more scores. So 76, 77, 78, 79, 80, 81, 82, 83 will be the top end of that interval. Then continuing in the next interval with 84, 84, 85, 86, 87, 88, 89, 90, 91. And then finally 92 would start my last interval, and we'd go 92, 93, 94, 95, 96, 97, 98, 99. And now I have 4 intervals that will encompass all of the different scores that were earned on this history exam. Okay, so now that I have the intervals set up, now I want to do a tally, and that simply means as I go through the list, I put a tally mark in that cell, in that square, to represent that that is a history exam score in that interval. So we had a history exam score of 68, which will go in this interval. We had a score of 72, also in this interval. Then we had a score of 76, which moves us to the next interval, a score of 81, a score of 84, which now moves us here, and then we had 3 86s, so 1, 2, 3 tick marks for that, a score of 89, so there's 5, and a score of 91. And then we had a score of 95 and 99. So then in my frequency column, I actually just write the number. So here I had 2 tick marks, so my frequency is 2. Here I had 2 tick marks, so again, frequency is 2. Here I had 6 tick marks, so I have a frequency of 6, and 1 more set of 2. So in this case, since my history exams were already in order, it was pretty simple to make the tally and make the frequency. But if you have scores that are all mixed up and they're not in order, this is an easy, nice way to get things kind of sorted out into these classes or intervals or bins, a lot of different names for kind of the same thing, and allows us to see just what the frequency in each interval would be. Okay? And then finally, we can use this then to make a histogram. So a histogram is a type of graph that has wide applications in statistics. Histograms allowed a visual interpretation of numerical data, it's got to be numerical, by indicating the number of data points that lie within a range of values, called a class or a bin. The frequency of the data that falls in each class is depicted by the use of a bar. So it looks a lot like a bar graph, but there are some very keen differences. And one of them is that there is no space in between the bars, which makes sense because if we think about the the frequency table we just set up, from interval to interval, we would always pick up with the next number, so we're not allowing any space between the intervals. So our histogram shows that by being side by side. Okay, and then again, each bar represents an interval of numbers. So you'll see here, I actually took this picture with our little hand cursor over this bar, and you can see here it's showing me what that bar represents. So it's showing me that I'm going from a score of 68 included up to a score of 76 not included. So it means it's really going up to a score of 75, which is what our first interval was in the frequency table. Okay, 76, if I actually had the calculator, if I moved my hand over here, then 76 would be on this end with the included sign, and our 83 would be on this side with the not, or excuse me, 84 would be on this side with the not included sign, so everything up to 83 would be included. Okay, so it's a little bit strange the way that they show this on the TI Inspire, but they are showing the same thing that we had in our frequency table. This is still an interval from 68 up until 75, because the 76 is not included. And then you can see here that my bar represents 2 points, which you can see from the graph itself, but it's also telling you here when you put your cursor over it. Okay? So, a lot to sink in. Just come to class tomorrow kind of knowing what these things are, what the different graphs look like, some of the features of them, and then tomorrow we'll talk about how you actually can get these graphs from data using your TI Inspire and what kinds of things you can do to analyze your data using these graphs. Okay, so I hope that wasn't too confusing. If it was, go back and rewatch a part here or there. But come to class just knowing what these are, and we'll pick up from there. And we'll see you next class.